All right, so let's get started. Welcome everyone to the first webinar for Jazz Computing, and thank you again for your patience as we are sorting out through the different difficulties this morning, learning a bit about how to live stream. So thank you for your patience. What we're going to talk about today is on what AI operators know, but AI investors don't know yet. And one of the things that's very critical for AI investment is to be able to de-risk the different components of the investment. Over the last 18, 20 months, I've been talking with a number of investors, specifically within the context of Jazz Computing. The firm, it's an AI boutique firm that I founded here in Silicon Valley, who is focused on helping investors with services around evaluating AI investments. And in this context, I've been talking to them to understand what are their main pain point that they see today with AI investments, but also at the same time, from the other angle, bringing in the AI operator angle based on my expertise. Just very quickly introducing my background. I've been in the industry as well as in academia for about 25 years total, and both in industry as a founding engineer of Google Cloud in 2011, then as the tech leader in Meta, leading the machine learning platformization effort over there, FP Learner, for some of you who are familiar with it. Then at Microsoft Azure, actually before that at Microsoft Azure, where I helped migrate Fortune 500 companies to Azure Cloud, learning about what does enterprise need in order to be able to migrate to a new technology, specifically within cloud and specifically within AI. And then most recently as the director of engineering at Apple, managing a multi-billion dollar ARR product, AI capabilities specifically. In addition to that, I have my doctorate degree and postdoc, MIT and UC Santa Barbara, as well as a master's in business management from Stanford, where I continue to be guest lecturer today and go back as a visiting research scientist from now and then. And in this context, I've been talking to investors over the years, but specifically in the last 18 months since the launch of ChatGPT, on their investment thesis in AI. And what I have seen and observed recently is that most investors are falling into a dilemma. On one side, what we're seeing in the market is astronomical valuations for AI startups, leading to investors not really able to connect it to any fundamentals for the system, any ARR or revenue. But at the same time, they have to invest. They feel that they have to invest. They go for a smaller number of portfolio companies within every fund, and that leads to a riskier portfolio per fund and a higher financial risk for them. Yet, they feel that they have to invest because of the recent inflection in the AI technology world have led to a potentially big next AI giant being built as we speak today, and therefore a significant risk of them missing out of it. So this dilemma we call the AI investor fatigue versus the AI investor FOMO. And I have heard it repeating over and over and over from different conversations that I have had with various investors, small and big, Silicon Valley based or New York based or even Middle East based or Europe based. So it seems like a recurring theme across different geos, across different investors, across entry level versus large investment portfolios, or Series A versus Series E, and so on. Having said that, what I've noticed being an operator for this number of years is that when we compare AI deals, they are very different from a risk profile than what we have seen historically or before that in the last several years, in the last decade or so, than SaaS companies and than software companies, for a number of reasons. One of them is the technology maturity. Technology is not mature yet, especially in productization. We're going to talk a little bit about that. Market maturity, especially from characterizing ROI for the different ideas, regulatory and legal risk, the innovator dilemma, small versus big tech, and where things are going to land, talent risk. We all know that AI talent is very expensive and very rare to find the right talent. Infrastructure risk with current GPU pricing, but most importantly, and the one that I've seen consistently missed in different conversation, is the scaling and operational AI risk. And in my mind, this is as significant, if not more, than everything that we have identified earlier from a risk profile point of view, and definitely different than what we have seen over the last decade from a SaaS investment point of view. Let me tell you why. And in order to do that, I'm going to share a little bit of technical slides. I promise I'm not going to go too much into the technical description of it, rather than just to highlight how software design and development and SaaS development is different than what we're doing today in AI model development, and how it lends itself from a risk profile point of view to investment in AI later on. But to start, if we compare between the traditional SaaS/software development that we have been doing for the last 1 or 2 decades versus the current AI model development that is the standard in the industry, there are some significant differences. The first one being linear development. You start with requirement collection, product requirement collection, gathering, asking customers, coming with clear requirements, hand it over to the engineers. Engineers start implementation, hand it over to testing and SRE in order to be able to validate it, take it to production, and then basically as more bugs comes in, as more issues comes in from the online service, you basically start fixing these, but most of the investment are put and are made ahead of time, right before you go to production. In this case, most of the outcome in that system, not only linear development, but most of the outcome is also deterministic, meaning for every system that you are, for every input A that you put into the system, you're always going to get an output B. So it's not going to come, like different at different times, rather than it's going to always be deterministic. This is what we call the term in computer science. And then lastly, the QA assurance is usually, like QA testing. We have a QA team, or unit testing, part of the software development, through unit testing, integration testing, through a number of other tests that are done, that are basically regression testing, in order to make sure that we're, creating a high quality product that we're putting out to the market. The case here is very different when it comes to an AI model development. Not only is the AI model development an iterative process, so you get the data, the training data, you train the model, and then you have hundreds or thousands of stochastic models output, because you want to experiment with the different kind of features that you add, different weights, different basically characteristics of the model, sometimes even model architecture, and then you put it through testing before you choose one of these hundreds or thousands of models, in order to be able to decide whether this is the one is going to be promoted to production, or whether you're going to go back to the basically drawing board and develop more models that have bigger potential hypotheses in order to be able to test in production, in order to promote one of them later on for production. So the process here is very iterative. You train, you put an inference, you train again, you put an inference, you train many models, you put one of them in production, large scale, and you do A/B testing all the process. Very iterative, not once and done. And also the outcome here is stochastic. And this is based on, basically the nature of the model. The model is a very, the capability of the model by definition is that based on the weights that you train the model on, the outcome might be A or B or C or D, depending on the data, depending on the model architecture. And this is part of the power of why AI today is very powerful, and part of why it's kind of a new paradigm shift of its own. Having said that, on the other hand, this also introduces quite a significant risk from how do you test such a model. And the best practices today in the industry is through experimentation and A/B testing. I'm going to dive a little bit more into that later, but the key takeaway from this slide, and hope you hold on if you're not a technologist here, is very different development cycle, very different outcome, and therefore very different practices for quality assurance, making it even harder to realize that actually the AI model development is part of the entire traditional software development that we're working with. Because an AI model does not live on its own, rather than it lives within a SaaS application that have some SaaS components before, SaaS components after, and SaaS components that are running hand in hand in parallel with the component, with the stochastic model, making it even much harder to be able to basically clarify and ensure the quality of the product as we're putting it into production. This gave a rise to a new field that's called machine learning operations, or MLops. You might have seen different, names for this field around, whether AI ops or whether LLM ops, or whether it's, so there is, different iterations around this name. However, MLops is basically the set of practices of integrating software development with the machine learning workflows with the goal of efficiently build, deploy, monitor, and manage the machine learning models in production. And the goal here is to be able to produce a reliable, reproducible, and responsible model and system in the end of the day. So what does that mean? What does machine learning operations integrate and include? It includes experimentation, tracking, and launching. It includes the feature engineering and the training of the data and keeping track of the data and its distribution. It includes the model quality and the performance validation, data and model monitoring, and being able to debug it, data pipelines and data management. But most importantly, alerting and logging, being able to alert when things change from a distribution point of view for the model, and incident response. And it brings the best practices from different fields, whether it's DevOps, whether it is data ops, or whether it is SRE practices. So very new field that have been getting a lot of traction. And the reason this is important because it actually introduces and addresses at the same time a new AI operational risk from an investment point of view. And I'm going to connect it to everything that we have been saying from an investment point of view in a minute, but just to highlight the complexity of this, as I highlighted, it's not only that we're developing one model and putting it in production, but the case here is that we're experimenting with hundreds or thousands of models, depending on the use case, depending on the capabilities that you have within the infrastructure and within the company, and being able to see which of them works best in production, creating what we call the continuous experimentation as part of the machine learning development cycle. And the best example that you might be familiar with in this case is A/B testing that have been done with Netflix in the very early days. And if you remember when Netflix launched their online service, a streaming service, they came up with this really interesting experimentation, which is for the thumbnail of the different movies that they are showing to the different users, the thumbnail would change per user, depending on what the specific user is more likely to click on. And they do that through experimentation. They do that through A/B testing. And in this case, they had to launch hundreds of experiments at the same time, measure the response of different users, and use that in a very scientific method, experimentation, in order to be able to evaluate how the different experiments are achieving their results and which of them works better, coming up with a hypothesis and validating the hypothesis. And this, of course, includes a lot of statistical analysis, a lot of t-tests and confidence intervals for those of you who are statistically inclined. And one of the most challenges in this case is having a big enough sample size that you can be able to draw statistical conclusions based on it. Because if you have only 10 users per experiment, then this is going to be a challenge, not statistically significant enough results that you can draw from this. which relates very much to startups, because startups are small in size in terms of number of users in the early phases, and when they scale, they don't have the skill yet that's going to be able to enable them to do this kind of experimentation at like at scale, despite any funding that they might have, just a number of users towards the system. The point from this slide is that experimentation is important in machine learning, and it addresses some of the risks. However, what we need here is continuous experimentation in order to be able to come up with and validate hypotheses and be able to continue the development of machine learning within different startups and within different investments. And this introduces a risk to investors, but also can be addressed through continuous de-risking. This is all of the technical content that I have for today. So I'm going to just gather all of the threads together, specifically when we talk about risks, new risks that introducing through AI operations to different investment opportunities in AI deals. And one way to address these new AI operation risks is through the deal selection and then the continuous de-risking later on as part of nurturing the different AI investment within a fund portfolio. Whether in this case, during the deal selection, is to understand and highlight the mitigation strategies for each risk and align it well with the VC strengths in this space. And then once the selection is done, you go through continuous de-risking by de-risking the different points of identified risks through the phase. And one of the ways that you can do that is a comprehensive specialized AIDD with the very deep angle to that. This is one of the things that we actually advocate for at Just Computing, specifically in terms of integrating AI operational risks as one of the key components to success of a DD due diligence capability and due diligence comprehensive approach, whether it's only team, product, or market at the traditional SaaS, but also now AI operational readiness in order to make sure that machine learning operations is part of the early thinking capabilities that's integrated into different AI deals and continuously integrated at de-risking for the different AI deals throughout the process. And that might include many things. Machine learning operations, as I highlighted today, being one of them, but it also includes data readiness and governance, technology infrastructure, business alignment, among other areas. Thank you very much. That's all I have for today. We have future webinars that we're planning in this space. Hopefully we're going to start in time for the future ones. No technical difficulties for these, but feel free to sign up for our newsletter or follow us on LinkedIn, or feel free to schedule time with me to continue the chat on this space. And for